Hi, this is Ray Mao, a research fellow at Nanyang Technological University. I'm glad to present our recent research, GPTEval, a survey on assessment of ChatGPT and GPT-4. ChatGPT and GPT-4 are large language models developed by OpenAI. GPT-4 is the upgraded version released after ChatGPT. Both models were pre-trained with vast amounts of text data, learning to predict the next word based on the preceding text. For example, if given the text, the GPTEval paper has been accepted by, the models would predict LIEC calling 2024. Suppose there is a very long mystery novel and the real murderer appears in the last word of this novel. To predict the murderer, the GPTs need to fully understand the context and grasp some reasoning skills. By extensive training on large corpora, both GPT can comprehend and generate fluent language. They have broad knowledge and can provide detailed responses on various topics. They are flexible and adaptable in different applications, making them valuable tool in different scenarios. This survey was motivated by two main factors. Firstly, we aim to gain comprehensive understanding of the pros and cons of ChatGPT and GPT-4 based on existing assessment papers. We focused on their language proficiency, scientific knowledge, and ethical considerations, helping to inspire the development of stronger large language models in the future. Secondly, we wanted to identify the limitation of current evaluation methods. This knowledge could help future research conduct a more objective and effective assessment of large language models. This survey includes 49 assessment papers published between January 2023 and August 2023. These papers collectively evaluated ChatGPT and GPT-4 across 81 different evaluation tasks. We visualized the performance gaps between the surveyed GPT models and the baselines. Darker colors indicate larger differences, while lighter colors suggest smaller differences. Red signifies cases where the GPT models outperform the baseline, blue indicates where they lag behind, and teal represents gaps between the GPT model and the ground truth or human performance. Gray indicates where no comparison was made. ChatGPT and GPT-4 excel in language understanding and generation, particularly in iterative dialogues, enabling them to handle various NLP, reasoning, and evaluation tasks and provide explanations. But they fall short of being comprehensive AI system, especially in domains requiring specialized linguistic knowledge where expert models perform better. Overall, ChatGPT and GPT-4 perform comparable to baseline models in reasoning tasks and showing advantages in evaluation tasks over baselines. In comparison to humans, ChatGPT achieves higher accuracy in tweet annotation and agreement and performs similarly in causal reasoning tasks. In multilingual NLP tasks, ChatGPT often lags behind supervised learning baselines in most evaluations. However, Xu et al. And Huang et al. Introduced two challenging Chinese benchmarks that include linguistic tests. In these tasks, ChatGPT and GPT-4 frequently outperform other large language models, but compared to human or ground truth, the GPT still show significant gaps. ChatGPT performs satisfactorily in general science knowledge and can provide open responses to scientific questions. This is evident in comparison with baseline models, where ChatGPT often outperforms them. But ChatGPT can still make mistakes, particularly with questions requiring multi-step reasoning. Its high language proficiency can also make it challenging for users to assess the accuracy of factual information, leading to various ethical concerns. Fairness in AI requires model to be unbiased across the gender, race, language, and culture. Well, ChatGPT's responses were notably worse in languages other than English. It has significantly reduced the gender and race bias compared to early large language models. Robustness entails models maintaining performance with diverse inputs but ChatGPT struggles with noise data, outliers, and SQL injection, potentially leading to serious consequences like data leakage or denial of service attacks. Reliability demands that generated text be faithful. Despite efforts, ChatGPT and GPT-4, like other neural text generators, can produce hallucinated content. For example, in factor-based question answering tasks, ChatGPT did not show improvement over the earlier versions, making it unreliable in critical tasks such as scientific article writing or legal case summary. Toxicity concerns models generating harmful or offensive content. Although GPT models are designed to avoid generating such content, researchers found that ChatGPT could still produce offensive text, particularly through prompt injections achieved by role-playing. For NLP tasks with richer training resources, GPTs may not perform as well as expert models. However, they excel in scientific knowledge, surpassing early models according to extensive multidisciplinary testing. In fields like computer science and the law exams, GPT-4 has achieved accuracy level comparable to or even exceeding average human performance. On the other hand, GPTs can produce hallucinations, possibly because their pre-training focused only on learning what is right and not what is wrong. For instance, given the context, if an animal has wings and can fly, it's likely a GPT must grasp logic, common sense, linguistics, and science to correctly predict the last words, such as bird. However, if GPTs don't learn that if an animal has wings and can fly, it's a penguin is incorrect, they may struggle to differentiate penguin from other birds based on flight ability, leading to hallucinations about a penguin flying. This is because GPT likely learned from data that penguins are birds with wings. In reality, there are more incorrect examples than just the negations found in Cobra. Well, the case I refer to is just to explain the possible failures caused by the similar learning paradigm. It doesn't mean that the GPTs don't have the common sense like penguin cannot fly. Next, the inference process of GPT models differs from that of humans. Humans use two types of reasoning, thinking fast and slow. GPT models, however, appear to only use a thinking fast-like mechanism, completing a feed-forward propagation without further consideration. Humans, on the other hand, can spend more time pondering difficult questions, engaging in a longer process of iterative inference until reaching a satisfactory conclusion. Despite these differences, GPT models can capable of a certain type of reasoning tasks. Adding prompts like "let's think step by step" can enable GPT to use its output as a scratchpad, chaining together multiple steps to find a solution. This simulates a thinking slow process, although it's restricted to linear thought sequences and lacks the ability to backtrack and consider alternative paths. Finally, changes in the wording of the questions can alter the knowledge that the model displays. While additional training may improve its accuracy in various contexts, it cannot alter the underlying reality that knowledge is embedded in the specific textual context in which it is presented. Thus, changing the wording of a question, even if the meaning remains the same, can still result in an incorrect response. The concerns about the reliability of NLP evaluations are also analyzed in this paper. ChatGPT, as a commercial product, receives periodic updates that addresses identified flaws from earlier studies, making comparisons with different versions challenging. Moreover, incorporating datasets from various assessments during the fine-tuning can lead to data leakage and unfair assessments. The choice of prompts heavily influences results, potentially leading to biased comparison. For instance, in machine translation, different prompts can yield different conclusions. Other factors affecting NLP evaluation, such as the selection of evaluation datasets and matrices, and the design of human evaluation and the task formulation, remain relevant. Finally, evaluating certain key ability like creativity and logical reasoning lacks objective criteria or large-scale benchmarks, limiting the assessment's ability to capture the full range of GPT's capabilities. In this article, we discussed several ethical concerns related to the GPTs. Studies have shown that users may be misled by their scientific knowledge, highlighting the need for users to access human-generated source references to verify response reliability. Well, reinforcement learning from human feedback can help reduce biased, inaccurate, and toxic responses and improve user-centric output. It can also be influenced by biased human feedback, such as system gaming and positive reward circles, as well as complex social norms and cultural context. It's important to be cautious when using AI-generated data to train new AI models because this could introduce irreparable flaws into the resulting models. Our team conducted a comparative analysis of metaphorical cognition in ChatGPT and human minds using MetPro, a computational metaphor processing tool. We extracted target and source concepts from parallel answers provided by ChatGPT and humans to the same questions and plot the concept distribution in the figure. Compared to the diverse concept activated in human-generated language, ChatGPT primarily activated a specific set of concepts like the circled blue area in the figure, leaving many other unactivated and grayed out. This indicates a concept preference in ChatGPT's cognition, suggesting potential biases in its generated text. After reviewing the assessment papers, we have several recommendations. Firstly, we suggest adopting a task-agnostic evaluation approach in this domain. Many evaluations of ChatGPT and GPT-4 have relied heavily on benchmark data or task-specific inquiries, which can lead to issues such as data contamination during pre-training, variability in model performance across different prompts and tasks, and limited evaluation scope. Task-agnostic evaluation approaches offer a promising solution to these challenges. Secondly, we emphasize the importance of fundamental research. While ChatGPT, like large language models, have had a significant impact on the field of NLP, there has been a tendency to focus more on high-level application tasks rather than traditional computational linguistic tasks like syntactic or semantic processing. However, fundamental research in computational linguistics remain valuable because it provides insights into how humans perceive and use language besides developing applications. Thirdly, we recommend the regulation of AI-generated content. As generative AI continues to advance rapidly, regulatory frameworks must evolve to prevent the misuse of AI and AI-generated content. While the success of large language models like GPTs is largely due to their exposure to diverse human-generated content, without proper control, the volume of AI-generated content could potentially overshadow human-generated content, leading to a loss of diversity in human thoughts. Lastly, we suggest that future large language models may require advances in learning paradigms to avoid issues such as hallucinations and the lack of thinking slow. We have conducted research defining 7 pillars for the future of AI in another work, which may also be informative for the development of future large language models. Thank you.